Hello friends, how are you? In this video lecture of chemical kinetics, today we will see what is zero order reaction, examples of zero order reaction, integrated rate law for zero order reaction, half-life period in case of zero order reaction, and what is graphical representation in zero order reaction. To understand this video, watch this video till the end. अगर आपको पसंद आता है तो like it, comment it, share it and subscribe it. पिछले लेक्चर में हमने देखा व्हाट इज द रेट ऑफ रिएक्शन, व्हाट इज द ऑर्डर ऑफ रिएक्शन एंड व्हाट इज द मॉलिक्युलरिटी ऑफ रिएक्शन. We know that rate of reaction and a decrease in concentration of reactant per unit time simultaneously increase in concentration of product per unit time. Zero order, first order, second order, rarely third order. So today, zero order reaction. What are the examples of zero order reaction? डिकम्पोजिशन ऑफ अमोनिया. पिछले लेक्चर में हमने देखा डिकम्पोजिशन ऑफ अमोनिया, अमोनिया का डिकम्पोजिशन ऑन प्लैटिनम सरफेस. इट गिव्स नाइट्रोजन एंड हाइड्रोजन गैस. Why this is an example of zero order reaction? Suppose this is the platinum surface. ये प्लैटिनम सरफेस है एंड हियर एक्युमुलेशन ऑफ व्हाट अमोनिया मॉलिक्यूल्स. ये अमोनिया मॉलिक्यूल्स है. All these are ammonia molecules. Only lower layer of ammonia molecules are directly in contact with what? Platinum surface. जब अमोनिया का डिकम्पोजिशन होगा, so decomposition of only lower layer of ammonia molecules. Upper layer and these ammonia molecules which are present in upper layers are away from platinum surface. Again I increase the concentration of ammonia, but these ammonia again away from platinum surface. यानी decomposition of ammonia does not depend on concentration of ammonia. Decomposition of ammonia does not depend on concentration of reacting molecules. And we know that a reaction in which rate of reaction is independent on concentration of reacting molecule or reacting molecules, that reaction is said to be what? Zero order reaction. So decomposition of ammonia on platinum surface, example of zero order reaction. Another example, decomposition of nitrous oxide, again on platinum surface. It gives nitrogen and oxygen. Again, this is an example of a zero order reaction. Here also rate of reaction does not depend on concentration of nitrous oxide. Photochemical formation of hydrochloric acid from hydrogen and chlorine, and a reaction of hydrogen gas with chlorine in the presence of UV light, it gives hydrochloric acid. All these are the examples of what? Zero order reaction. Now, what is the integrated rate law in case of zero order reaction? Integrated rate law in case of zero order reaction, your title is integrated rate law in case of zero order reaction. A reaction in which rate of reaction, or that is the velocity of reaction, does not depend on concentration of reacting molecules. I will take general example of this. Suppose A to product or A to B. Here A is a reactant and B is a product. We know that what is rate of reaction? Decrease in concentration of reactant per unit time. Velocity. Rate of reaction is also known as the velocity of reaction. So, what is the rate of reaction? R is equal to what? Negative. That is minus d by dt of what? Concentration of A. Simultaneously, we know that increase in concentration of product per unit time. But here we have to think about reactant only, because we have to decide whether concentration of reactant decide the rate of reaction or not. That is why only decrease in concentration of reactant or rate of reaction. A negative sign क्या indicate करता है? Decrease in concentration. dt यानी time interval, initial time, final time, that is the final time minus initial time. dA, change in concentration of reactant molecule. Now what is the rate law? We know that rate law is simple mathematical equation in which rate of reaction is expressed in terms of what? Concentration of reacting molecule. Here इसका पावर जीरो होगा क्योंकि ये जीरो ऑर्डर रिएक्शन, वी आर डीलिंग विद जीरो ऑर्डर रिएक्शन और रेट ऑफ रिएक्शन. ये के क्या होता है? रेट कांस्टेंट एंड a to the power 0. We know that anything to the power 0 it is always 1. Now compare these two equations. Here left hand side exactly same, so right hand side will be same, and you can write from these two equations minus dA by dt is equal to k into a to the power 0 and it is 1. So this is a new equation. I will shift this dt to this side and equation will be minus dA is equal to k dt. Again I will shift this negative sign to the right hand side. Equation will be what? This is a new equation. dA is equal to minus k into dt. Equation number 3. Now integrate equation number 3. Integration of equation number 3 by integrating. Integration a mathematical concept है. By integrating equation 3. Now here we have to think about limits of integration. When time is 0, when t is equal to 0 and initial, then concentration of reacting molecule it will be A0. It will be A0. After certain time t, when t की value t होगी, तो concentration of reactant क्या होगा? It will be AT. And A0, this is the initial concentration of reacting molecule. And what is AT? AT is the final concentration of reacting molecule. Initial time is 0 and before starting the reaction start होने से पहले t is equal to 0 and after certain time t, and final time क्या है? t है. So integration of this equation by integrating this equation, so integration of dA, limits here initial, lower limit and initial concentration and upper limit that is AT. ये upper limit है is equal to minus k constant है, we can take outside of the integration, k integration of dt. Here lower limit is 0 and upper limit is what? T. Now integration of dx. We know that integration and derivative, these two are opposite processes. ये cancel होगी, integration derivative cancel होगा, it is x plus c. ये c क्या है? Integration constant है. यहाँ पर integration of dA. So what is integration of dA? Integration of dA is what? Integration derivative cancel, it is only a. Integration of dt, ये क्या होगा? t. Now integration of dA, it will be only a. Here lower limit is a0, upper limit is what? at is equal to minus k as it is. Now what is integration of dt? It is a t. Lower limit is 0, upper limit t. Now put these limits. at minus a0, upper limit minus lower limit, यानी at minus a0 is equal to minus. अभी इसका upper limit है t, lower limit 0 है, t minus 0 खाली t होगा. It is a kt. Same equation you can write. Suppose equation number 4. I will multiply equation number 4 by minus 1. माइनस 1 से मल्टीप्लाई करूंगा, ये माइनस माइनस क्या होगा? प्लस होगा, यानी इट इज ए kt. kt इज इक्वल टू, नाउ at ये माइनस होगा और ये माइनस प्लस होगा, यानी इट इज a0 माइनस at. Therefore k is equal to initial concentration that is a0 minus at divided by t. ये k क्या है? रेट कांस्टेंट है. A0 initial concentration of reactant, AT final concentration of reactant after time t. A small t क्या है? टाइम है. So what is unit of rate constant? अब इसका unit, this is very important. Unit of rate constant. Unit of rate constant. न्यूमरेटर में कॉन्सेंट्रेशन है, कॉन्सेंट्रेशन अपॉन टाइम. सो कॉन्सेंट्रेशन अपॉन टाइम. व्हाट इज यूनिट ऑफ कॉन्सेंट्रेशन? मोल्स पर डीएम क्यूब. मोल्स पर डीएम क्यूब यानी डीएम टू द पावर -3 अपॉन टाइम यानी टाइम इनवर्स. सो दिस इज द यूनिट ऑफ रेट कांस्टेंट इन जीरो ऑर्डर रिएक्शन. क्लियर? नाउ ग्राफिकल रिप्रेजेंटेशन इन जीरो ऑर्डर रिएक्शन. ग्राफिकल रिप्रेजेंटेशन. I will take this equation. Kt is equal to A0 minus A0 minus AT. I will shift this AT to the left hand side and KT to the right hand side. So here it will be AT is equal to, इधर जाएगा तो माइनस होगा KT. ये ऑलरेडी पॉजिटिव है, दैट इज A0. You can compare this equation with straight line equation, that is y is equal to mx plus c. ay at. m क्या होता है? स्लोप होता है. m is slope. And what is the value of m here? Your value of m is minus k. यहाँ पर स्लोप नेगेटिव है. So what is the graphical representation? I will plot the graph. Concentration of reacting molecule against time and reaction progress. On x-axis I will take time and here concentration of reacting molecule. It is like a straight line, but slope is negative. With time, as the time increases, concentration of reactant decreases. Straight line. So graphical representation will be like this. ये slope क्या होगा? ये slope negative है. Slope it will be negative. Here m is minus k. So this is the graphical representation in case of zero order reaction. यानी concentration of reacting molecule decreases with time, and as the time increases, concentration of reacting molecule decreases. Now half-life period in zero order reaction. Half-life period in zero order reaction. Initial concentration of reactant is A0. It is A0. ये initial concentration है. इसका half concentration क्या होगा? इसका half concentration होगा A0 by 2. इसके लिए जो भी time लगेगा, that time is said to be what? Half-life period. So for this I will take Kt is equal to A0 minus AT. Same equation you can write T is equal to A0 minus AT divided by K. A0 initial concentration है, AT ये final concentration after time T. So here we are dealing with half-life period. अब ये T क्या होगा? T will be T half. And after T half, what will be the concentration of reacting molecule? So this AT will be what? This AT will be, after half-life time, it will be A0 by 2. Yani it is A0 upon 2. Put these values, then time T is equal to T half and AT is equal to A0 by 2 in this equation. So equation will be T half A0 minus A0 by 2 divided by K. Now solve this. This is very simple. यहाँ पर एक है 2 into A0, 2A0, 1 into A0, it is minus A0 divided by A2, ये 1 upon K, 1 upon K. So what is the final equation? Here T half is equal to, now 2A0 minus A0, it will be what? A0 divided by 2 into K, it is 2K. So what is the conclusion? In case of zero order reaction, half-life period is directly proportional to, and half-life period depends on initial concentration of what reacting molecule. Listen again. In zero order reaction, half-life period of reaction, half-life period is directly proportional to concentration of what? Initial concentration of reacting molecule. Yani half-life period depends on initial concentration of what? A reacting molecule. So this is about zero order reaction. Examples of zero order reaction: integrated rate law of zero order reaction, graphical representation in case of zero order reaction, and half-life in case of zero order reaction. If any doubt, you can put your doubt in comment box. Definitely I will get back to you. Thank you.